I'm starting the discussion again on R1 values. This has been discussed a lot, and I think we should not discard R1 values as a tool to estimate protection in the field. But it still depends on the vaccine quality. So what was the objective? Mainly for how do we interpret R1 values? We now have of Purbright uses the traffic light system. This is good and not, and is that still adequate? Or should we take vaccine quality into account? And I believe that we should take vaccine quality into account. If you look at, I like to look at all data because a lot of people think that we do research and we have to move on again, and I think ignoring all data is sometimes a little bit a pity. So if you still recent papers, but using old strains, people showed that old strain like Ocampos 1953, it was or 58, it was isolated, still protects against viruses circulating in South America. So you also in South America you have evolution of virus, although the evolution is limited, probably due to vaccination. But if you go to another continent, they also show that you have good protection. And then I will be the sixth person who brings up these BRAME studies, and you also see good cross protection with good potent vaccine. But in this case, as is shown here, then you clearly see that these vaccines had really high potencies homologously. Then I googled cross protection, and the first picture I got was this one. But so I think good vaccine. First, I was a little bit. I thought, what does it mean? Because I was thinking about vaccines, and I thought, why do I get these pictures? But it took some time for me to realize that good vaccine should provide cross protection, because you can select the last strain you had in your vaccine, but your vaccine is not for the last strain you had, it's for the future strains that are coming. And you never know what is coming, and you should have good cross protection, and we should also have a good test for cross protection. So the best test for cross protection is, of course, a potency test where you compare the potency test with homologous challenge and a heterologous challenge, because then you can really compare quantitatively how vaccines compare. But that is quite expensive, and if you could estimate your homologous potency by serology, that would be an advantage. So what I did, I was looked at literature on quantitative cross-protection studies, and I calculated the potency ratio. And the potency ratio is the ratio between heterologous potency and homologous potency. So a lot of people that already know the R1 value clearly recognize it's very similar to R1 value. And so I wanted to see if these R1 values relate with this potency test ratio. And for the R1 values, I looked at the published R1 values in the paper, but also from Purbright I got the R1 values from strains within the same topotype, and I calculated the average and the geometric mean R1 value and the 95% confidence intervals, just to have a little bit more data. Now, I looked at the scopus, and I found in total that 53 papers were in, 5 were only valid. Looking at the references, I found 3 additional studies. Several experiments had high homologous potency, that's mainly the BRAME studies. And there was one study that reported the antigen amount needed for 1 PD50 and not the volume needed for 1 PD50. So this was excluded from the regression. And not for all the combinations I found in literature, there were not always data from on R1 values from the Purbright Institute. So if you look at these data, I must admit that on one hand it's a little bit around the globe, and but still we have a regression gives a significant relation, but with a slope of 0.9, which is close to what you would expect, and 43% of the variation is explained. But of course, that's, I saw already Richard pointing at that one point, has extremely high leverage in this model. So, yeah, as every researcher said, we need more data, but I think we have more data. So, and also, do we have to test it on a normal scale, or on a log scale probably is even better. So more studies are needed, and perhaps we should also include strains with an R1 value of 1, as for instance the Egnazia 10 times testing. You could say, you know, we take the average outcome of 10 times testing and see, and we add that to the model, because then the R1 is exactly 1. And in yellow are the ones from the BRAME study, where you also have the problem that the homologous potencies were quite high. So there is still some things we can add. And also then, oh, the wrong button. What you see is that we still have a few studies in which we don't have the data yet. So that will be very interesting, because this has a low potency test ratio. We still have to get the sera for testing. It's a study done in a commercial company, and we have to have agreement on sharing the sera. And here we still have to do, there was another one, that one. We still have to finish all the analysis, which was a previous study. But what you also see, that there are quite huge confidence intervals with some of the studies. So it still has limitations, and we have to also think how we better standardize our R1 value determination. But if you would look at the consequences, if you would assume that the 3PD50 per dose vaccine would protect against an outbreak strain, then if the R1 value is 0.1, we would give it a red sign nowadays, but you would say, no, we need at least homologous potency of 14. So that's a much clearer answer what kind of vaccine you have to buy. Not just saying you have to buy a vaccine that matches, but you can buy this vaccine with that potency, or that one with a lower potency. And that's a much clearer answer, I think, for people to decide. And at least it also shows that we have to have data on homologous potency for the vaccines that are available. And so the main conclusion is that R1 values correlate with protection. We hope that there is, of course, also a lot of variation in the potency test ratio, but can we reduce that variation in R1 values? We have to think about how to standardize it. And every advice on vaccine strains should take the vaccine quality into account. Okay, that was my last slide.